For your review, I would emphasize studying orthographic projection. It's the topic I value the most for your learning outcomes in this course. It's the most useful to you going forward when you want to build a project. You'll realize you have to have the true size and shape of the various pieces of material that make up your project, and they have to be drawn in an ortho view in order to convey to your reader the true size and shape. So this is just fundamental learning that we've gone through, and it might be a little bit convoluted in your head right now because you've had to add to these basic principles of ortho how to draw an AutoCAD. Well, that can muddy up what you think you're doing. So let's just review the basics of ortho. Typically, we have a front view, and remember, in as a drafter, you would want you'd always want to orient the front of the object to be that complex side that you want to give the reader the most information you can about this overall object by facing the complex side to the front. In exams and in your homework, you're told what is the front face, but in real world, you pick the front face. So in this example, the front view has a edge that describes a tunnel going through it. So that's this through tunnel. And then on the top view, it has a through hole. This also includes center mark notation and hidden line notation. I noticed when I'm doing the homework checks that a lot of students still have trouble locating their hidden lines. So you might want to really study this graphic, print it, and really try to understand how the views are related. This view shares the width with the view above it. The front view shares the height with the view to its side. And the side view and the top view share this depth, right? They're equal. This is just a fundamental thing. And I still feel like students struggle with it regularly. So don't feel bad if you have to practice this basic orthographic principle. This is the PowerPoint that was given to you on day 8, and there's a missing line problem here where the PowerPoint stepped through you trying to solve where the missing lines are on these views. And I think this would be an excellent place to spend some time before the exams, just going through this missing line problem, making sure you get the fundamentals of the object lines, the orthographic method, and then the precedence on the hidden line and the center line, annotation line. So after you've looked at your orthographics, you might want to look at the isometric PowerPoint that I told you was on day 12. This is down a few pages, 12 pages into that PowerPoint. So it's quite a long PowerPoint. But here's a nice exercise for you to go over some basic ortho and isometric learning that we've done here. Also, this example object is very much like an object on one of your worksheets, and some students puzzled pretty hard on this object. It's a combination of a stepped profile, so the edge is stepping up, and you can see that on the right side. But then on the face here, on the front face, you see there's a sloped line, meaning that something is foreshortened. So it's a combination of this area over here in the top view, the sort of sawtooth area, is foreshortened. It's this slope down below. And then this square matches up with this surface and this surface. This rectangle matches up with this surface over here, the middle step, and if you bring down this line here, it's this length, right? And then here's your final step. There's its length, there's its width, there its view is in the top. Anyway, I recommend you step through these panels where you draw this object You look at it in ortho, because I think that's a very good object to be looking at in ortho and understand, and then how to convert that over to the lines that create an isometric pictorial of a 3D object based on the true size and shape that you're given in an ortho. One of our major learning objectives. So I hope you'll practice that a little bit. On day 17, there's a PowerPoint for your roof pitch. This is page 2 of the PowerPoint, just a quick graphic that shows the rise and the run that creates the roof pitch that we use to draw in AutoCAD. And the run corresponds with your x-axis, so your horizontal distance, and your rise corresponds on your y-axis in AutoCAD to your vertical distance. And that creates this slope, which if we were looking at in ortho, like if we were looking at the top of this house in ortho, this would be called the foreshortened slope, because we could not really see the true size and shape of it from the ortho top view. We have to see it from combination of sides to get all the information to describe this plane, which is running not parallel or perpendicular to a ortho axis. Rise over run. Our next topic that we'd like to review is the dimensioning, which has a lot of rules. You know, everything's got to be a certain size, certain space. But that's all so that your drawings, when completed, look familiar to people in different trades that are using them. So it's part of our using standards in AutoCAD. We don't just invent the way things look when we're doing architectural and engineering drawings. We use a uniform standard style of annotation. It depends on what trade you're in and what standards you're following that you actually use them. You set those up with your templates, right? Save time so you don't have to recreate styles over and over again. You share styles between drawings. But there are some basic line rules that you'll want to be sure you know for your tests, and that is that the dimension line is the line between the arrowheads that has the distance on it. The extension line is traveling along the edge of the object up to the dimension line, giving the reader a clue as to what the dimension relates to. Leader lines extend radially from the center of objects out to the side where the text is for the annotation. And they all have style controls that are in the dim style settings. We've also looked at oblique pictorials. This is from the oblique pictorial PowerPoint that came out on day 21 in your modules. We've been using the 45 style oblique, but depending on your object, you may have to use a different angle to convey what you need on a standard piece of paper. So sometimes it's the object dimensions versus the paper size that forces you into one of these different angles. And we also use the oblique pictorial with the cavalier, so the full dimension scale on the side, and then also the cabinet oblique where they are drawn with half scale depths. And that would be something you want to make sure when you're reading questions that you're very clear about what the question is asking, and then you might want to find this if it's related to this obliques details, you might want to refer right back to the PowerPoint during the exam, because this is not the kind of information that you may be super strong on because we've only just recently covered it. So give yourself a minute to look up this material and make sure that you answer your questions correctly. Don't just guess this stuff. You can use your PowerPoints to make sure that you're answering your questions correctly. So let's look at sections. This is from the reading on sections. It's a rather lengthy amount of reading on sections, but this is one of the pages in the reading, and I think it illustrates important topics that might be on the test, because I think students in general have a little trouble understanding the orientation of the section view to the other views. One thing maybe I've not emphasized enough with students is that the section view, so let's look at this one here, section AA. This is a standard top ortho view. It has a phantom line on it, and the view that's behind the arrowheads is the one where the section drawing is going to occur. But the section drawing is really the same as the standard ortho drawing in that position. So in this case, the front view. It's the same overall size and dimension as the standard front ortho view. It's just that once you've drawn the outer dimensions and even the inner features, then you have to apply the cutting plane concept and say, okay, I'm going to remove all of the physical material that's blocking my eye from this phantom line out in this direction, and my eye is going to see the revealed interior areas when that line is applied. And so in B, you'll see that the phantom line is on the front ortho view. So that means that the view that's going away from these arrowheads, that would be the top view, you're going to show the section on the top view. So in this case, the block is cut through the top, through the front view, and this is what's revealed. But again, you'll see like the depth of this axis is the same as the depth of this axis, just like a standard ortho drawing. So the section drawing is not different than an ortho drawing. It's just that at the point where you're getting it finished, you consider, okay, I've removed, like in this case, I've removed all this material here so that the right side is looking at this revealed edge, this revealed hole, this revealed edge. And they're visible lines now. You've got section lines and then visible edges, where if this was a standard ortho view, it would look like the top, the hole would be hidden, and you'd have a center line. You still have the center line in the section view, but the hole is no longer hidden. The edge of the hole is revealed. So get to know your section's orientation and how these phantom lines apply. That would be my recommendation. Then on day 25, we had a PowerPoint on auxiliaries, and this is page 4 of day 25 PowerPoint. And it shows the basic layout of trying to draw an auxiliary plane view using ortho views. And I think sometimes when I look at students' work, I realize there's some things that maybe are just generally confusing to students. But please remember, when you see a diagram like this, this is your usual ortho view, right? This is the side of the object in ortho. There's an edge right here, and there's a slope, right? A foreshortened slope. And we've seen this numerous times. This over here is the standard right side of the front ortho. And then the process that's in this PowerPoint is to draw this surface A so that it's ortho to this surface, right? So it's a translation. And that's how you can show the true size and shape of this slope right here. It's not the true size and shape, it's foreshortened. This is the edge profile, and this is a foreshortened slope. So if you want to have an accurate drawing of that surface A, you have to put it in auxiliary. So that it looks like this. Anyway, That concludes my review of our major topics for your final exam.